So children, our calculation is complete. 100 minus L, and then I have calculated y, right? Now it's time to draw the graph. This is now what you are supposed to write in your exam copy and in your practical copy is you are supposed to draw this circuit, which is the main thing of this experiment. And then this observation table is very, very important. Look at the observation table. Whatever reading we have taken from the scale, that is up to 1 decimal point, because least count of meter scale is 0.1 centimeter. Then just look at this column. I have mentioned all the calculation here only. So this is the proper way to write your practical in your practical exam, so that you are getting full marks. Then calculation of y, just look at the way I have written. I have written the whole fraction, which is, that means values substituted in place of these two, and then I have written the result. Unit, no unit, but all the columns where the quantity has unit, that unit is mentioned. 1 ohm, 2 ohm, 3 ohm, they does not have any they does not have 1.0 type of representation, because they are either 1 ohm or 2 ohm or 3 ohm in the resistance box. So least count of the resistance box is 1 ohm in fact, right? Then slope is calculated using the graph. So now we switch to the graph formation. So this is the graph, and now I am explaining you the important things which you have to take care in the graph. I have already explained in the previous experiment also, and here also, because these are the things which I have seen that children does not know. So I am repeating it again. Now look at the first thing. Draw x and y axis, and then on x axis we know that we have to plot the resistances we have taken out from the resistance box. So 1, 2, 3, 4, 5 ohm. But the thing which you have to pay attention is that I have taken a large scale on the x axis as well as on the y axis, because according to the rules you should have a large scale so that 60% of the graph paper is covered with the graph, because a large scale is a sensitive scale and it is more accurate. So instead of taking 10 small divisions equal to 1 ohm, I observed that I can write all the 5 ohms here. So I have taken 20 small divisions equal to 1 ohm on the x-axis, and the scale should be uniform. I am mentioning again, kink is not allowed. Kink is not allowed. I am mentioning again, beta. Kink is not allowed, like maths. So it is 0, then this is 1, and if I want to choose my origin something else other than 0, and say if I take it 1 ohm, then after 20 divisions, if I am taking 20 divisions, small divisions equal to 1 ohm as my scale, then after 20 divisions I have to write 2, then 3, then 4, and so on. So kink is not allowed, right? Then on y-axis, observe the readings which I have to plot. I have to plot the smallest reading 0.50, and they have mentioned it. This is also one thing which I want to clear you. They mentioned that calculate y up to 2 decimal places. So I have calculated and then rounded off the y up to 2 decimal places, and I'll try that I can take large enough scale on y-axis also, so that I can plot the second decimal place also. to make my graph as accurate as possible. Now 0.50 is the lowest and 2.40 is the highest reading I have to plot. So I observed that if I can plot 20 small divisions equal to 0.5, this is 0, then this is 0.50, next 20 divisions 1, 1.5, 2 and 2.5. So it is possible in this graph that I can take 20 small divisions equal to 0.5 units. And we don't have to write 1 centimeter or 2 centimeter equal to this much on x and y axis as we do in maths. Here we will write in terms of small divisions. So 20 small divisions equal to 0.5 unit on y axis and 20 small divisions equal to 1 unit or 1 ohm on x axis. And I have mentioned after plotting, after scaling the x and y axis, I have mentioned here that y, which is equal to this much, is plotted on y axis and x, which is resistance, is plotted on the x axis, and this is important. You have to mention these two things, what you are plotting on x and y axis. So proper scale, the quantity with proper units and no kink, and then mention the scale here. Now when it comes to plot the points, then see what is the technique. On x axis there is no problem, 1, 2, 3, 4, 5 ohm, and you just have to take 1, 2, 3, 4, 5 ohm. On y axis we are having up to 2 decimal places, up to 2 decimal places we have to plot. So see what is the technique. I calculated here that I have taken 20 small divisions equal to 0.50. So 1 division will be 0.50 upon 20. That comes to be 1 upon 40. Now if 1 division is equal to this much, then 2 division, 1 upon 40 into 2, calculate it and you will find 0.05. Similarly 4 division, 1 upon 40 into 4, that is 0.1 unit. Now why I have taken 2 divisions and 4 divisions? Because if I move 4 divisions on y axis, I will get 0.1 unit increased. If I move 2 divisions on y axis, I will get 0.05 unit increase, and this is the important, because if I have to plot say 0.50, then it is directly plotted 1 ohm and 0.5. This point is easily observed and plotted, but just look at this 0.96 unit y and corresponding resistance is 2 ohm. So just look at the technique. 2 ohm is alright, but 0.96, now observe it carefully. I will start from 0.5. 1, 2, 3, 1, 2, 3, 4, 0.6. If we move 4 divisions on y axis, then we increased y by 0.1 unit. So here it's 0.6. Next 4, 0.7. Next 4, 0.8. Next 4, 0.9. And we have to plot 0.96. When we reached 0.9, then I observed that if I move 2 divisions, then I will get 0.95. If I move only 1 division, then I will get 0.95, and 1 division is 0.025. That means I will get 0.95 plus 0.025, that is 0.95. 0.975. So either I can plot 0.95 or I can plot 0.975. 0.95 is close to 0.96, so I plotted here, only moved 2 and I plotted here 0.95 because I cannot plot 0.96. Either I can plot 0.95 or moving one division up I can plot 0.975. Getting this point? Next very important point, these points should be very small sharp dot. I am explaining here this with the help of the ink pen, that is why you got this untidy look here, but points should be very fine. The pencil should be very fine and thin. All these are carrying marks with them. Then similarly, if I have to plot 1.88, so accordingly, as I told you the technique, accordingly I calculated 1.88 for 3 ohm. Just look at 1.88. No, for 3 ohm it is 1.40. So just look at this is 1.5. So just 4 divisions below this I got 1.40. Because 4 divisions, you come down 4 divisions and you decreased the value of y by 0.1. Are you getting the technique? And then for 5 ohm, you have to plot 1.88. So for 4 ohm, so for 4 ohm, 1.88. Now I started counting from 1.5. I started counting from 1.5 and I reached to this point, which is 1.85. Now either I can plot 1.85 or I can plot 1.9. So I opted 1.8 instead of 1.85, or I can plot 1.875. So I opted 1.9, but yes, you can take 1.875. This point was 1.85. अगर मैं सिर्फ एक डिवीज़न ऊपर जाती तो मेरे को मिलता 1.875. So I should correct it. I should take it 1.875, which is closer to 1.88. I corrected it, children, and now it is 4 ohm and 1.875, that is approximately 1.88. So for 4 ohm we got 1.88 approximately. So actually we have plotted up to 2 decimal places. And then for 5 ohm it's 2.40, which is the value of y, and I plotted it according to the same technique. 2.5 is here, so come down by 4 divisions and you will get 2.5 or 2.4, right? So this is the way you are supposed to plot the graph up to 2 decimal places. Take the larger scale and then plot the things calculating like this: value of 1 division, 2 division, 4 division. This will give you clear vision how to proceed on that axis in which we have to plot up to 1 decimal place or 2 decimal place or 3 decimal place. Now we have plotted it and we are asked to calculate the slope. I again remind you, we don't have to use the observation points to calculate slope. We have to take any 2 random points to calculate slope, and those 2 random points should be far apart. Now I have taken 1 point here. I dropped perpendicular on x-axis and perpendicular on y-axis. I have taken the value of x2, that is 4.2 ohm, and y2, that is 1.95, according to the calculation I have explained you here. The scale I have taken, that scale helped me to find y2. Then I have taken another point here, dropped perpendicular on x-axis and y-axis. According to the scale, this point is 0.9 ohm and this point is 0.45 ohm. According to the scale, as I have explained you, I have found y2, y1 and x1. Now simple. Now take the readings: x1 0.9, x2 4.2, y2 0.45 and y1 0.45 and y2 1.95. And now we are going to calculate slope. First you write the formula, then substitute the value of y2 and y1. Right, 1.95 and 0.45, x2 and x1, and calculate the slope. Y does not have any unit and x have unit ohm, so the unit of slope is per ohm. Never think that slope does not have any unit, slope have units. Then they asked us to calculate a quantity R, which is 1 upon slope, and that we have calculated 2.2 ohm. Now in the analysis of the circuit, I explained you that they are asking us actually to calculate the value of this resistance, which is 2 ohm. So look at the result. Result within the 30% allowed error, result is quite close to 2 ohm. So this is perfect result. We have written result R is equal to 2.2 ohm. Take care of this thing. They asked us to calculate slope up to 3 significant figure, and I explained you this is not a scientific way, but this is a very good trick, that read the number, and if all the numbers which you can read in one go are significant, like here you can read it 455, 0 you cannot read, so the significant figures are 3. If you add 1 0 here, then you can read 4550. So that 0 which is here, you can read that in one go. So then if 0 is added here, the significant figure will become 4. But if 0 is here, you cannot read it in the number, so significant figures are 3. And they asked us to calculate R up to 1 decimal place, so all the instructions are taken care. Y up to 2 decimal place, all the instructions are taken care. So now I am showing you all the readings, circuit diagram, which you are supposed to write in your practical copy. So this is your experiment for 2018, question number 1. This is complete experiment with the graph. And in the next video, I am going to explain you one more thing, that is the resistance wire, diameter of resistance wire is taken using screw gauge. And just one more quantity K is being asked to calculate, and that is the experiment of 2014, 16, 2004. So in the next video, I am going to explain you that part in which we have to find the diameter of the resistance wire using screw gauge.